Page 5. We're gonna do 2 word problems today. So what did I say this whole chapter is about? Hayden? Wow. Tell me something I don't know, will you? Okay, what are the 2 methods that we learned? Like the 2 important lessons. One? The quadratic formula. Okay, and William, the other one? Sorry?
Completing the square.
Complete the square, right. So those are the 2 methods that we learned in this whole chapter, and that is what the whole chapter is about, the 2. So now, if I put it in a word problem, you need to know when do you do what, okay? Otherwise, if you do the wrong thing, you're just wasting your time. So recall, to find the vertex, we use complete the square. In the word problem, where's your vertex?
Height.
Right, the maximum height or the minimum point. Okay, so the maximum or the minimum point. Okay, and when do we find the x-intercepts? Yep, to use the quadratic formula, or we can solve by factoring. And in word problems, it's usually like when it lands. So when is it on the ground? When does it land? Like just like when the grasshopper, where does it hit the ground? So forth. Okay. So example 1, an entrance arch will be built at the new McDonald's. The designer used the equation this to model the arc, where h is the height in meters and d is the horizontal distance. Okay. How wide and tall is the arc? Okay, so how wide means I'm solving for the x, right? And how tall? The y, the vertex, right? So let's do that. So we want to do the quadratic. Okay, so h equals negative d squared plus 16. This is page 5. Yeah. I could either do by factoring or I can do by quadratic. Okay. Which one do you guys want to do? Quadratic. But technically, this one is a very easy factoring. Can oh sure, okay, but just looking at this, can you already tell what my 2 x-intercepts are?
Yeah.
What is it? Take a wild guess. It's not 6, 7. It's a perfect square.
8. 4.
Wait, what? Negative 1b. Negative 1b. 4.
Okay, Cindy? 1 and 4. Okay. Gavin?
4 and negative 4.
4 and negative 4, right? Alright, I'm gonna show both ways, but as I said, you can do either or. Okay, so I'm just gonna show the factoring way first, and then I'll show the quadratic formula way. So this difference of square, it has to be minus in the middle. But I could take the negative out so that it's like this. And then if I factor it, I can easily see now is that d plus 4, d minus 4. So then my 2 x-intercepts would be d equals negative 4 and d equals positive 4. Okay, so this is the factoring way. Factoring method. Okay. As you guys say, you like the quadratic formula method more. So what's A, what's B, what's C then?
A is 1.
Well,
Negative.
negative 1. What's B?
0.
0. Good. And C?
And C
16. Right. Sub it into the quadratic formula. So x equals, or in this case it's d because they didn't use x, they used d. Same thing. So d equals negative b plus or minus root b squared minus 4ac all over 2a. Okay. By now, have you guys memorized the formula?
Yeah.
Good. If you haven't, you have a week. Okay. -0, that's gone. That's just 0. And then 0, so this is square root plus or minus. So it's still 0 plus or minus. Square root 16 times 4 is 40. No, 64. Thank you. Okay, over -2. Okay, so which gives you plus or minus 8 over -2, because root 64 is just 8. So then your two answers, one is 8 over -2, and one is -8 over -2. And guess what you get? 4, -4. Okay. So now that you looked at both methods, who still likes the quadratic formula more? Oh, sure. It is more steps, more work, but if you like it, it works. Okay. So now if I were to do a quick little sketch on this. Okay. -4, +4. Okay.
What's
This.
-4? -4 or 4?
You don't. Yeah. Okay, so this is the entryway. So they just made an arc. Okay. So how wide is the arc? William?
8 meters.
8 meters, right? So in between, that means it's 8 meters. Okay. And how tall is the arc? So which means this right here. Okay. What is that point as well? What is that point also called?
The y-intercept.
The y-intercept. And what is it? 16. How did you know it's 16?
In your equation had +16, and since it's standard form, the last number is the y-intercept.
Perfect. Okay. So the equation, just based on the equation, I know already that it's 16. Another method you could do, remember, your vertex is in the middle of your 2 points. So that means that's 0. When d is 0, what's h? So it's -0 squared plus 16, you get 16. Okay. Part B of the question. If a width of 2.5 meter is needed for each line up at the entrance, how many lines can there be? So this architect decided to make it interesting and make lineups right here. So like making lines, make lines, make lines, make lines right here. Okay, so how many lines can I make?
4.
So 8 divided by 2.5. 8 divided by 2.5. I need a calculator. 2.2? 3.2, right? 8. My calculator doesn't work. 8 divided by 2.5. So 3.2. Okay, so that means I can fit I can fit 3 lines right here. So 1 line, 2 lines, 3 lines. So
0.2.
3 lines. Can you have 0.2 of a line? So 3 lines for them to buy the very expensive McDonald's now. Nowadays, a Big Mac costs like $10 and it's not even filling. Yeah, especially filet o fish. I like it, but I feel like I ate nothing. Okay. So that's number one. Right? So number one is just basically getting you guys to recognize that if it's asking you how wide, you're talking about your x, and then how tall, you're talking about your y. Okay. Example two: the path of a basketball after it's thrown from a height of 1.5 meter is given by the equation that where h is the height in meters and d is the horizontal distance in meters. How far has the ball traveled horizontally to the nearest tenth of a meter when it lands on the ground? What do you think we're solving for then when it lands on the ground? Are we solving for x or solving for y? X. Good. Yes. So when it lands on the ground means I'm looking for my x-intercept. All right, let's draw the little diagram.
Wait, when I ask a question, how are you supposed to know, like, if it's asking for X or Y?
That's what we're doing right now. So we're practicing. So whenever it's asking for vertex, it's talking about the height, the y, and then when it's solving for the x-intercept, it's like you're solving for the x-intercept, which means when does it land? Yeah. So that's why we're doing these practice right now. You for the last few days you learned the skill, so now is applying it to word problems. Okay. So I'm just doing a quick little sketch. What's my y-intercept here other than William? Sydney? 1.5 right here. Okay, so this is 1.5, and the path of the basketball goes something like this. Okay, and so you're trying to figure out when does the ball hit the ground? Right there. So it's your x-intercept. And so if I want to find my x-intercept, what are my two methods? Factor or quadratic formula? Quadratic. Quadratic formula is easier. Okay, especially if your equation is given to, well, actually, let me rephrase that. Depends on the equation I give you. If I give you in standard form, quadratic, definitely. If I give you in factor form, then factor is much easier. Okay, so A, B, and C. What's my A? What's my B? What's my C? Jaden, what's A? What's B? What's C?
It's 0.5, 0.5. No, 0.25.
Good. Okay. Okay, let's try to put it into the formula. Okay. Mila, have you memorized the formula? Yeah. You think so? Okay, can you plug in the numbers for me? Good. Negative b plus or minus root. Mm-hmm. Yeah. Perfect. Good job. But you can sound more confident in your answer. It's perfect. Okay. So now just let the calculator do all the work for you inside this radical. So negative 2 plus or minus. What do you get? I don't like this calculator. I missed the one that I had. 0.25 times 1.5 plus 4. Sydney, what did you get in the radical? Oh, what did you get? Okay, good. I got that too. Over negative 0.5. Okay, what is square root 5.5? 2.2. 2.35. Okay. So D equals -2 plus or minus 2.35 over negative 0.5. Okay. So now I can do my two answers. So this one is going to be -2 plus 2.35 over negative 0.5. The other one is going to be -2 minus 2.35 over negative 0.5. Okay. Okay. -2 plus 2.35 divided by negative 0.5. I get negative 0.7. And then on this side, 2 minus 2.35 divided by negative 0.5, I get, did I do something wrong? Yeah, I did something wrong. Yeah. Yeah, it shouldn't be symmetrical. -2 minus 2.35 divided by 0.5 negative. There we go. Yes. Okay. And how did I figure out I made a mistake? Because looking at this, I know it's not symmetrical. Okay. So a diagram does help. Okay. In this case, should we reject an answer? Yes. Why? Right. I'm not throwing the ball out of bounds. Okay. So, but why does it still give me two answers if only one of them makes sense? Right. All right. Good. Good explanation, Gavin. All right. So even though this doesn't make sense, it's still part of the whole parabola. So the equation of the parabola doesn't know what you want and what you don't want. It's just a representation of this. So that's why this right here is negative 0.7 and negative 0.7, which we are going to reject. And so we're just taking this. What is the unit here? Be careful. Careful though. Leandro? Meters. It's not seconds because if you take a look here, they say height is in meters and D represents horizontal distance in meters. So this is you, and you threw it 8.7 meters away from you, okay, which is a pretty good throw. Okay, so this is 8.7. So how far does the ball travel horizontally to the nearest tenth of a meter when it lands? There you go. Find the horizontal distance when the basketball is at a height of 4.5 meters above the ground. Okay. What am I trying to solve for? Am I solving for X or Y for B? Yeah. You think it's Y just because we solve for X in A? Well, I gave you one. We have 4.5. So what are we looking for again? It's not always just solving for vertex. What are we looking for? X. We're still looking for X because see, find the horizontal distance, which represents X. Okay, so where is this 4.5? 4.5 is the height. So this is a tricky question. So 4.5, I'm going to sub in 4.5 here. And then negative 2.5d squared plus 2d plus 1.5. Okay, and then what do you think I have to do with this 4.5? But before I can do that,
You have to plug it in.
I plugged it in. Is this in standard form?
No.
No. So what do I have to do with this 4.5? Move it over, right? Move it over. So that I get this, that, plus 2d So 1.5 minus 4.5 minus 3. Now is this in standard form?
Yeah.
Yes. And so if I want to solve for D, what method am I doing? Quadratic formula again. Yes. Okay, but this time, notice your A, B, and C are different values. A is negative 0.25, B is 2, C is negative 3. So what was different is the C is negative 3 this time. And then yeah, it's so sick and tired because you're doing quadratic formula again. But this tells me if you actually understand what you're looking for. It's not always part A is X, part B is vertex. Okay, so let's sub it in. Negative 2 plus or minus root B squared minus 4AC all over 2A. Okay. So negative 2 plus or minus root, what does that give you? 4 times 0.25 times 3 is 3. So 4 minus 3 is 1. Yeah. And then negative 0.5. So then you have negative 2 plus or minus 1 over negative 0.5. Your two answers. So D equals negative 2 plus 1. And this one is the negative 2 minus 1. Okay, so negative 2 plus 1 divided by negative 0.5, I got 2. 3 divided by 0.5, I get 6. Okay. Which answer do I reject? Neither. Why? Let's look at that diagram right here. Okay, William, why?
Find the middle points to get the y.
I don't need to find a y, but so what I just found, I also don't need that. Okay, so what I just found here was the 2 and the 6. Andy.
Points on the x-axis where like the height is above 4.5.
Right. Why is there 2 points? I hear the O. Sydney, why is there 2 points?
Because the balls around 4.5 meters for both on both the points.
Right.
You know what I mean? Like
okay, but on a test, I need a better explanation now.
Like after and before those points, the ball is below 4.5.
Okay, Leandro?
It's the 2 points where they're at 4.5.
Yeah, but why is there 2 points? Think logically. You're throwing a basketball. The ball goes up and down, right? This is the way the ball going up, and then this was the ball coming back down. So there's actually 2 points of where the height is at 4.5, at the 2-meter mark and at the 6-meter mark. If this was like in seconds, for example, if this was a second question, then after 2 seconds, it's at 4.5, and then on the way back down, it's also at the height of 4.5. Okay. Does it make sense? Yeah. Okay. But so this part in the past, this part is where people had trouble with. I'll put it better for you to take the picture. Let me see. So a lot of time when people see this question, the part B, they're like just like how you guys said, you guys are thinking, oh, vertex. I'm probably looking for vertex. So with this one, you have to read the question carefully. Oh, thank you so much. Thank you. So if it asks you for the horizontal, anything horizontal, it means you're looking for the x. Right? When it asks you how tall, that's the y. Okay. Based on so an extension to this question. Let's say I ask part C. What's the maximum height reached by the ball? Then what am I looking for? Ethan? The vertex. And what's there's two ways that we can look for vertex now. What's one way? Plugging in the x-intercept is not going to help me find a y. Yeah.
0 plus 8.7 divided by 2.
Not 0, but yeah, it was negative 0.7. Yeah, so I could find the middle and then find the x and then plug it into here. That's one way to find a vertex. And the second way, completing the square, what we did on Monday. Okay, so we're gonna try that tomorrow when we do the completing the square and that part. Okay, so for homework tonight, just to get you guys started on 2 word problems, page 290. Page 290. Remember, answers are given on the back, so make sure you do check it. This pile is a little messed up with the page numbering. Right, so page, so page, yes. So page 290. All right, so page 290. Let's do number 8, number 9, and number 12. Okay, so just these 3. Just 3 word problems, and then tomorrow we'll do 2 more examples, and then I'll assign a few more word problems. Okay? Sure.